In this video, we're going to start the KutaSoftware Infinite Algebra 1 free worksheet, Properties of Exponents. So for this video, I'm going to complete numbers 1 through 10. And our instructions are to simplify. Your answer should contain only positive exponents. So in this first part of the worksheet, we're going to be dealing with the product rule. And the product rule says that if we have a to the x times a to the y, that is equal to a to the x plus y. So if we have the same base, we are able to add those exponents together. So looking at number 1, I'm going to rewrite this. Since everything is multiplied together, I'm going to write it as 2 times m squared times m to the third. 2 times 2 is 4, so I'll have 4 times m, and think about it, m to the 2 times n to the 3, a to the x times a to the y, I can write as a to the x plus y, so I can write this as m to the 2 plus 3. So this is going to be 4 times m to the 2 plus 3, which is m to the 5th. 4m to the 5th is the solution in number 1. In number 2, I'll rewrite this as 2 times m to the 4th times m to the negative 3. So that's 2 times m to the 4 plus negative 3. So 2 times m to the 4 plus negative 3, or 4 minus 3, is 2 times m to the first, which m to the 1 is simply m. So 2m is the solution in number 2. In number 3, I have 4r to the negative 3 times 2r squared. I'll rewrite this as 4 times 2 times r to the negative 3 times r to the positive 2. 4 times 2 is 8, so that's 8 times r to the negative 3 plus 2. Negative 3 plus 2 is negative 1, so I have 8 times r to the negative 1. However, remember my answer should only contain positive exponents, and r to the negative 1 is the same as 1 over r to the 1. So I'll write this as 8 times 1 over r to the positive 1, which r to the positive 1 is r, and 8 times 1 is 8. So I'll have 8 over r as my solution in number 3. In number 4, I'll rewrite this as 4 times 2 times n to the 4th times n to the negative 3. 4 times 2 is 8, so I'll have 8 times n to the 4 plus negative 3, or 4 minus 3. N to the 4 minus 3 is n to the 1, or n to the first. So I'll have 8 times n to the first, or 8n in number 4. And number 5, I'll rewrite this as 2 times 4 times k to the 4th times k to the first, since k is equivalent to k to the first. So 2 times 4 is 8, and I'll have k to the 4 plus 1. Since I'm multiplying exponents with the same base, then I'm going to be adding those exponents. So it'll be 8 times k to the 5th, since 4 plus 1 is 5. In number 6, now I have 2 different variables, so I'm going to rewrite, trying to group my variables together. So I'll start with my whole numbers, 2 times 2, and then I'll write my x values, so times x to the third, times x to the negative 1, and then I'll do my y values, so times y to the negative 3 times y to the positive 3. Y to the negative 3 times y to the positive 3. So this will be 2 times 2, which is 4, times x to the third times x to the negative 1 is x to the 3 plus negative 1, or 3 minus 1. And that will get multiplied to y to the negative 3 times y to the 3, which we can rewrite as y to the negative 3 plus 3. Because remember, if they have the same base and those are multiplied together, then we can add the exponents. So this will be 4 times x squared, since 3 minus 1 is 2, and then times y to the 0, since negative 3 plus 3 is 0. However, y to the 0 is equal to 1, because any number raised to the 0 is 1. So y to the 0 is also 1. So my final solution is just 4x squared. And you can see why simplifying is important. The original in number 6, before it's simplified, is a lot more than 4x squared. If you notice, we were able to cancel out that other variable and put it in terms of one variable, since the exponents when added together equals 0. Therefore, simplifying is very important when dealing with exponents. In number 7, I'll rewrite this as 2 times 3 times y squared times x. 2 times 3 is 6, and y squared cannot be combined with x, so this will just be 6y squared x, or 6 times y squared times x. Because remember, you can only combine terms with exponents when they have the same base. So even though x has an exponent of 1, the bases y and x are not the same. Continuing on to number 8, I'll rewrite this as 4 times v to the third times v times u squared. Now v to the third times v is the same as v to the third times v to the first. So we'll have 4 times v to the 3 plus 1, and then that will be multiplied to u squared. So I'll have 4 times v to the fourth times u squared as my solution in number 8. 4v to the fourth times u squared. And number 9, I'll start by multiplying 4 and 3 together to get 12. Now I'll combine my bases of a. So I'll have a to the 3, and then I'm going to be adding that to negative 4 or subtracting 4. And then finally I'll multiply that to my bases with b, which is b squared, so b to the 2 plus negative 3, or minus 3. So that's 12 times a to the negative 1, since 3 minus 4 is negative 1, times b to the negative 1 as well, since 2 minus 3 is negative 1. I'm going to need to rewrite them as 12 times 1 over a to the first, which is 1 over a, times 1 over b to the first. And that's because when you have a negative exponent, you apply the negative exponent rule that says a to the negative x is equal to 1 over a to the positive x. That is why a to the negative 1 can be written as 1 over a to the positive 1, and same with b to the negative 1. However, a to the first and b to the first would just be a and b in the denominator, so I'll multiply my numerators, 12 times 1, which is equal to 12, all over my denominators, a times b, so a, b. Therefore, in number 9, my solution is 12 over a, b, or 12 divided by a times b. And lastly on this worksheet, I'll go over number 10. If you haven't already, like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. In number 10, I'll rewrite this, starting with my bases of x, I'll have 2 plus 3. So x to the 2 plus 3, and I'm going to be multiplying that to my bases of y with the exponents negative 4 plus 2. So that's going to be equal to x to the 5th times y to the negative 2. Now remember, my answer needs to contain a positive exponent, so I need to rewrite y to the negative 2, so I'll have x to the 5th times 1 over y to the positive 2. So now I'll multiply my numerators. X to the 5th is the same as x to the 5th over 1, so x to the 5th times 1 is x to the 5th, and 1 times y squared is y squared. So I'll have x to the 5th over y squared as my solution in number 10. If you have any questions, feel free to leave them in the comments below. And if you didn't do so before number 10, like this video and subscribe to my channel. In this video, we're continuing on with the Properties of Exponents worksheet under the Infinite Algebra 1 section on the KutaSoftware website. In this video, I'll do numbers 11 through 20, in which we'll go over the power rule for exponents, and we'll also talk about the power of a product rule. Now for the power rule, if we have a to the x, and we're raising that to the y, we can simply do a to the x times y. So in number 11, if we have x squared to the 0, we can write x to the 2 times 0, which is x to the 0, and any number raised to a 0 exponent is equal to 1. So in number 11, we can simplify x squared to the 0 as 1. So now that we've went over the power rule, let's go over the power of a product rule. So if we have a times b to the x, so that product raised to some power, then we're essentially going to distribute that exponent. So we'll then have a to the x times b to the x. So in number 12, we're going to be distributing that negative 4. So we'll have 2 to the negative 4th times x squared to the negative 4th, which I'll rewrite as 2 to the negative 4th times x to the 2 times negative 4, remembering our power rule. So 2 to the negative 4 times x to the 2 times negative 4 is x to the negative 8. And remember, our answers cannot contain negative exponents. So remember that we can write a to the negative x as 1 over a to the positive x. That is the negative exponent rule. So if we have 2 to the negative 4 times x to the negative 8, we can write that as 1 over 2 to the 4th times 1 over x to the 8th. Multiplying the numerators, we'll get 1, and then 2 to the 4th is equal to 16. So I'll have 16 times x to the 8. So 1 over 16 times x to the 8th is our solution in number 12. I have 4r to the 0 and then raising that to the 4th. So that's 4 to the 4th times r to the 0 and raising that to the 4th. 4 to the 4th is equal to 256. So 256 will be multiplied to r to the 0 times 4. And 0 times 4 is 0. So 256 times r to the 0, which is equal to 256 times 1, which is 256. That's our solution in number 13. In number 14, we have 4a cubed, and then we're squaring that quantity. So distributing that exponent, we'll have 4 squared times a to the 3rd squared. 4 squared, 4 times 4 is 16, and that's going to be multiplied to a raised to the 3 times 2. And a to the 3 times 2 is a to the 6th. So we'll have 16a to the 6th as our solution in number 14. Now I'll distribute that exponent of 4, so we'll have 3 to the 4th times k to the 4th, that quantity also raised to the 4th. So it'll be 3 to the 4th, which is 81, times k to the 4 times 4. So that's 81 times k to the 16th. Now for number 16, instead of distributing this exponent at the start, I'm going to rewrite this as 1 over that quantity to the positive power. Because remember, a to the negative x is equal to 1 over a to the positive x. So taking this entire term for xy, I'll have 1 over 4xy to the first. However, even when I distribute that exponent, 4 to the first is 4, x to the first is x, and y raised to an exponent of 1 is y. So I'll have 1 over 4xy as my solution in number 16. In number 17, same thing. I'm raising this to the negative 1, so that's the same as writing 1 over 2b to the 4th to the positive 1, which is 1 over 2b to the 4th. Since when I distribute that 1 in the exponent, I'll have 2 to the 1st, which is 2, and then b to the 4 times 1, which is b to the 4th. In number 18, I'll distribute that exponent of 2. So I'll have x squared squared, and I'll have y to the negative 1 squared. So that's x to the 2 times 2 times y to the negative 1 times 2, which will be x to the 4th, since 2 times 2 is 4, and y to the negative 2, since negative 1 times 2 is negative 2. However, we cannot have negative exponents, so we need to rewrite the term y to the negative 2. So continuing my work, this will be x to the 4th times 1 over y to the positive 2. So that's x to the 4th all over y squared. In number 19, again, I'm raising this to the negative 1. However, I'm going to distribute this negative 1 to two separate quantities as opposed to 3. So I'll have 2 times x to the 4th, raising that to the negative 1. So you see I didn't split it up and distribute it to the 2 and x to the 4th. I just distributed it to the positive terms first, and then I'll also distribute it to y to the negative 3rd. So it'll be y to the negative 3rd to the negative 1st. Now I did this because my exponent here was negative, whereas my exponent here and here is positive. So when I rewrite 2x to the 4th to the negative 1st, that will be 1 over 2x to the 4th, and I'm raising that all to the positive 1 within the denominator. However, for y, I'm going to multiply it out, so I'll get y to the negative 3 times negative 1, which, writing this out again, I'll have 1 over 2x to the 4th times y to the positive 3. So my y to the 3rd will remain in my numerator. So that's y to the 3rd all over 2x to the 4th. That is my solution in number 19. And again, I split the distribution up. Since these had positive exponents, I know they would eventually be in the denominator when I distributed the exponent of negative 1, and since this y had a negative exponent, I knew when I distributed that negative 1, that exponent dealing with the y would become positive, therefore putting it in the numerator. Let's continue on to number 20, the last problem I'm going to complete in this video. In number 20, I'm going to start by writing this term as a fraction. So I'm going to have 1 over 3 times m to the positive 2. And then I'll distribute my 2. So I'll have 1 over 3 squared times m squared. So that'll be 1 over 3 squared is 9, and m squared is simply m squared. So 1 over 9m squared is my solution in number 20. Now if I wanted to, I could have started by distributing that negative 2. So then, if I did that first, I would have 3 to the negative 2 times m to the negative 2. Which would be 1 over 3 squared times 1 over m squared, which would be 1 over 9 times 1 over m squared, which would still get me to 1 over 9 times m squared. So I would still get the same answer regardless of whether I distributed the exponent first or whether I created the fraction first and then distributed the exponent. Either way, I'll get 1 over 9m squared for number 20. If you haven't already, like this video and subscribe to my channel. If you have any questions, leave them in the comments below, and feel free to share this video with your classmates. In this video, we're going to finish the Properties of Exponents worksheet, easy, on the KutaSoftware website under the Infinite Algebra 1 section. Now, in the first video for this worksheet, we went over the product rule. In this video, we're going to be dealing with the quotient rule, which has a similar concept. So a to the x divided by a to the y is going to be equal to a to the x minus y. So we're going to be subtracting those. So if we were to multiply, we would add. However, since we're dividing with these exponents, we're going to be subtracting. If you need to see it in fraction form, it's a to the x over a to the y. That's equal to a to the x minus y. So looking at number 21, we have r squared over 2 times r to the 3rd. So pulling that 2 out, but leaving it in the denominator, we'll have 1/2 times r squared over r cubed, which we will write as 1/2 times r to the 2 minus 3, which is 1/2 times r to the negative 1. And remembering that negative exponent rule, we will put 1 over r to the positive 1. So this will be 1/2 times 1 over r to the positive 1, which is equal to 1 over 2r for number 21. And number 22, splitting up this fraction, I'll pull out that 4, so I'll have 1/4, and I'll be multiplying that to x to the negative 1 over x to the fourth. So I'll write this as 1/4 times x to the negative 1 minus 4, which will be 1/4 times x to the negative 5, since negative 1 minus 4 is negative 5. So that can be rewritten as 1/4 times 1 over x to the positive 5, or 1 over x to the fifth, and simplifying again, multiplying my numerators, I'll get 1, and multiplying my denominators, I'll get 4x to the fifth. So 1 over 4x to the fifth is my solution in number 22. For number 23, I'll have 3 into the fourth over 3 into the third. So I'll have 3 over 3 times into the fourth over into the third. 3 over 3 is 1, so I'll have 1 times into the fourth over into the third is into the 4 minus 3. So 1 times into the 4 minus 3 will just be in to the 1, which we can write as the variable in. In number 24, I'll write this as 1 over 2, or 1/2, times m to the fourth over m to the fourth, which is 1/2 times m to the 4 minus 4, which is 1/2 times m to the 0, which any number or variable raised to a power of 0 is simply 1. So that's 1/2 times 1, which is equal to 1/2. In number 25, I'll have 3 times m to the negative fourth over m to the third. So that's 3 times m to the negative 4 minus 3, which is 3 times m to the negative 7. So when I rewrite m to the negative 7 as 1 over m to the positive 7th, multiplying that by 3, I'll get 3 over m to the positive 7. And number 26, I'll have 2 over 3 times x to the fourth over x squared times y to the negative fourth over y to the negative third times z to the negative third all over z to the positive fourth. So this will be 2/3 times x to the 4 minus 2 times y to the negative 4 minus negative 3 times z to the negative 3 minus positive 4. So that's equal to 2/3 times x squared times y to the negative 4 minus negative 3 is negative 1 times z to the negative 3 minus 4, which is negative 7. So I'll rewrite this as 2/3 times x squared times 1 over y times 1 over z to the 7th, remembering my negative exponent rule. Now I'll simplify that all, multiplying the numerators. I'll have 2 times x squared all over the denominators multiplied together, which is 3 times y times z to the 7th. And that's my solution in number 26. Now remember, x to the 0, or any number to the 0, is 1. And 4 divided by 4 is also 1. So I'll have y to the negative 2 times z to the third all over x. However, I cannot have a negative exponent in my answer, so I'm just going to rewrite y to the negative 2, moving it to the denominator. So that's going to be z to the third in the numerator all over y to the positive 2 times x. And that's y squared, or y to the positive 2 now, because I moved it into the denominator. So z cubed all over y squared times x. In number 28, I have 2/3 times h to the third times j to the negative 3 all over j times k to the fourth all over k. So that's 2/3 times h cubed times j to the negative 3 minus 1 times k to the fourth minus 1, since j and k both have exponents of 1 in the denominator in the original expression. So now I'll have 2/3 times h cubed times j to the negative 3 minus 1, which is j to the negative fourth, and then I'm going to be multiplying that by k to the 4 minus 1, which is k to the third. So my j to the negative fourth will be written in the denominator. So I'll have 2 times h to the third times k to the third all over 3 times j to the fourth. And that's because the 3 with the h is positive, the 3 with the k is positive, but the 4 is negative, so that j is going to be going into the denominator. I'll start by having 4 thirds. Then I'll have m to the 4 minus 2. So m to the 4 minus 2, and then I'll multiply that to n to the 3 minus 2. So times n to the 3 minus 2, and then I'll multiply that by p to the 3 minus 4. So p to the 3 minus 4. That's equal to 4 thirds m squared times n to the first, which is n, times p to the negative 1. However, the p has a negative exponent, so I need to move it into the denominator. So that's 4 times m squared times n all over 3 times p to the first, or 3p. So I'm doing the same exact steps that I've been doing it, I've just written this a different way. I've just kept my math all in the same fraction as opposed to splitting the fraction up. Now lastly, for this worksheet, we're going to go over number 30. Before I work through this problem, please like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated, and they just let me know that you're finding these videos useful. So now, on to number 30. I'm going to start by simplifying. I have two bases where the exponent is 0. That's y to the 0 and z to the 0. Both of those will equal 1. So I'll rewrite this as 3x to the third times y to the negative 1 times z to the negative 1 all over x to the negative 4. Now, I can write this as 3 times x to the third minus a negative 4, since x to the third is divided by x to the negative fourth, and then I'll multiply that by y to the negative first times z to the negative first. That's going to be 3 times x to the 3 minus negative 4 is x to the positive 7, and y to the negative first and z to the negative first can be written in the denominator as y to the first, which is y, times z to the first, which is z. So 3x to the 7 all over y times z is my solution in number 30. Now quickly note, another way we could have done this problem, or another way to do quotients, is to move that negative exponent into the numerator. So remember that a to the negative x is equal to 1 over a to the positive x. So if I have 1 over x to the negative fourth in my denominator, I could write that as x to the opposite of negative 4, which is x to the fourth. So then I could have multiplied x to the third times x to the fourth, which would have been x to the 3 plus 4, x to the seventh. So that just goes to show you that if I have a negative exponent, regardless of whether that negative exponent is in the denominator or the numerator, I will be able to flip it and make it positive. Now that we've finished up with this worksheet, if you have any questions, leave them in the comments below, and I'll get back to you as soon as I can. And remember, like, subscribe, and share.